Hello students, today we will discuss about Fourier transform. Fourier transform is very much useful for solving some particular type of partial differential equation with boundary conditions. Right, so what is the basic formula for Fourier transform? It is also known as complex Fourier transform. So what is the formula for Fourier transform? If you have a function fx, then Fourier transform of fx is equal to integral minus infinity to infinity f of x e to the power I u x dx, and the answer is in terms of u and represented by fu. Same way, if I take the inverse transform of this fu, I will get fx. And what is the formula for that? So f inverse of fu is equal to 1 upon 2 pi integral minus infinity to infinity fu e to the power minus iux du, and which will give you f of x. So usually this inverse formula is used when you are asked to derive certain extra result in the questions. But in this video I will do the direct question where I will be finding out only complex Fourier transform. In this video I will be covering very basic and simple questions so that the concept is very much clear to you, right? So now let us start with the questions. Along with the Fourier transform, complex Fourier transform, we do have Fourier sine transform, Fourier cos transform, FFT and DFT. FFT and DFT are very easy topics, and Fourier sine and cos transforms we will do later on, but in this video only complex transform I will cover. Okay, so let us start with the question. Now my first question is, find the complex Fourier transform of this function. Now before starting with this, I will explain you what is the meaning of mod x. This mod x can take two values. One is minus x and one is x. Minus x value is taken when x is less than 0. Okay, and this is taken when x is greater than 0. So now when I am saying ki mod x is less than or equal to a, it gives me two interpretation. One, minus x is less than or equal to a, and one, plus x is less than or equal to a. Now if I multiply this inequality by minus 1, I'll get x is greater than or equal to a. Now combine these two, you will get x is between minus a to plus a. So the meaning of this inequality is x is between minus a to plus a. Correct? Now I want to find out Fourier transform. What is the formula of Fourier transform? Minus infinity to infinity f of x e to the power iux dx. Correct? This you have to mug up. Now I can see that my function is defined in this range as 1 and remaining portion it is 0. So my integral limit will become from minus a to a fx is what? 1 into e to the power iux and dx. Okay. Now what is the integral of e to the power iux? E to the power iux upon iu, limit minus a to a. So 1 upon iu is common. Now let me put the limit e to the power I a u minus e to the power minus I a u. Correct. Now here what you will be applying. See, I will tell you the two formulas. What are those formulas? Sine of ax is equal to e to the power ax minus e to the power minus ax upon 2i. Right? So the moment I'll get this thing. Sorry. See, you have to understand it like this. What is e to the power I ax? It is equal to e cos ax plus I sin ax, right? And e to the power minus iax is what? Cos ax minus I sin ax. These all formulas you have studied in 11th grade in complex, right? If I add these two relation, what will happen? Cos ax is equal to e to the power iax plus e to the power minus iax upon 2. Same way, sin ax, if I subtract, sin ax is equal to e to the power iax minus e to the power minus iax upon 2i. Correct? Now let us substitute. So here what I got? Minus sign means sine. So 1 upon iu. So this will become 2i sine of AU from the same formula which I explained you. So I and I got cancelled. So I got 2 sine AU upon U, which is my answer. Very simple, right? Let's move to the next question. Now you have to find out Fourier transform of this function. Again, this inequality means x is from -1 to +1, right? So my integral minus infinity to infinity f of x e to the power iux dx. This will get converted into integral -1 to 1, 1 minus x square e to the power iux dx. Now how to integrate it? 1 minus x square e to the power iux. Now what is the differentiation of this? Minus 2x, minus 2, 0. E to the power iux upon iu. E to the power iux upon iu square. E to the power iux upon iu to the power cube. Make the cross lines. Right? Plus, minus, plus. Let me substitute here. So my first term is 1 minus x square e to the power iux upon iu. Okay. Then minus minus plus. So plus 2x e to the power iux upon I square u square. Then next term minus 2 e to the power iux upon I cube u cube. Minus 1 to 1. So now let me put the limits. When we put the upper limit 1, so because of this it will become 0. In second term if I put, I'll get 2 I square u square e to the power iu minus 2 e to the power iu upon I u cube, and this will become plus. I cube is what? I cube is I square into I square is minus 1. So basically minus I. So that is the reason this minus became plus, and in place of I cube I am left with only I. Correct? Now I will put the lower limit. To avoid the confusion, always put separately when terms are more. Now if I put minus 1 here, again it will become 0. Let me put minus 1 here. So I will get 2 minus 1 e to the power minus iu upon I square u square. Okay, minus 2 upon, again this will become I and this will become plus u cube e to the power minus iu. Correct? Now let me simplify this. Here if you observe, it is 2 e to the power iu upon u square, and I square is minus 1. We don't prefer to have I in the denominator. So this term I will multiply and divide by I. If I multiply and divide by I, denominator become I square, which is minus 1. So in numerator 2I e to the power iu upon u cube. Okay. Now minus, this will become, I square is minus 1. So minus 1 become plus. So 2 e to the power minus iu upon u square. Again here same thing, 2 I e to the power minus iu upon u cube. Now let me combine the like terms, like 2 upon u square. If I take out with negative sign, I have e to the power iu plus e to the power minus iu. This term and this term. So minus 2I upon u cube if I take, so e to the power iu minus e to the power minus iu. Right? So minus 2 upon u square. This is 2 cos u because it is plus. Minus 2I upon u cube. So this is 2I sin u. Correct? So now here 2 and 2 will become 4. So minus 4 cos u upon u square. Here minus 4, but I square will become minus 1. So plus 4 upon u cube sin u. So if I take minus 4 or plus 4 u cube common. So what is left here? Sin u minus u cos u. So this will become my answer. So let's move to the next question. Now you have this question. Again, this meaning x is from minus a to plus a. So again, if I apply the formula, I will be left with minus a to a x e to the power iu x dx. So how to integrate it? X and iu x. So 1, 0. This will become e to the power iu x upon iu, e to the power iu x upon I square u square. Make cross lines, plus minus. So I am left with x e to the power iu x upon iu minus e to the power iu x upon I square u square minus a to a. Let me put the limit. So upper limit when I am putting, so a e to the power iu a upon iu minus e to the power iau upon I square u square minus, now I will put lower limits, that is minus a. So minus a e to the power minus aiu upon iu minus e to the power minus aiu upon I square u square. Now combine the like terms. These two are same denominator. I will pick them together. So a upon iu, okay, in bracket e to the power iau plus e to the power minus aiu. Now this term and this term. So what is common here? I can take minus e to the power minus minus 1 upon, one second. So now I can take common minus 1 upon I square u. You should be very careful because it's easy, but small terms you should not miss and take care of the brackets. So what is left now? E to the power iau minus e to the power minus aiu. Okay, now here this is a upon iu and 2 cos au. Correct? And this is I square is minus 1, so plus 1 by u square 2i cos of au. Okay? And here, since I don't like I in the denominator, I'll rationalize it. So I'll get one I in the numerator. So denominator will become I square, because basically I am doing this I upon I. So I into I become I square. I square is minus 1. So minus 2ai cos au upon u plus 1 by u square 2i cos of au. Right? So now both terms are cos. No, one should be sine. This should be sine. Right? So what I can take common here? I can take 2i common. So I am left with sine au minus a cos au and u here upon u square. Correct? So this is my answer. Now let's move to the next one. So let's move to the next question. Okay, now next question is a mod function. So usually students get scared of mod function, but actually they are very easy. So now observe it very carefully. As I said, this limit is x is from minus 1 to plus 1. And mod function, if you are below 0, it is negative, and if it is above 0, it is positive. So I can rewrite the question f of x is equal to 1 minus of minus x. When I am saying 1 minus of minus x means negative, means I am talking about this range. So x has to be from minus 1 to 0. 1 minus of plus x. So x has to be from 0 to 1. Okay. Now this is the question. Again I will rewrite f of x is equal to 1 plus x and 1 minus x. This is when x is. Okay. Now let us apply the formula of Fourier. So what is the formula? Minus infinity to plus infinity, which I need to break from minus 1 to 0. Okay. 1 plus x e to the power iux dx plus 0 to 1 1 minus x e to the power minus iux dx. Okay, so now let us apply here. So first function, integration of second minus integral d by dx of first and double integration of second. Plus, let's go to the second one. First function, integration of second minus integral d by dx of first, that is minus 1, so this become plus, and double integration of this means e to the power minus iux and minus iu ka whole square, so I square u square basically, and the limit is from 0 to 1. Correct? So now let us apply the limits. So now when I am applying the limit to the first one, the upper limit is 0. So when I put 0 here, so 1 plus 0 is 1, e to the power 0 is 1. So 1 upon iu. Okay, minus. Here if I put 0 is 1 upon I square u square. So this is the upper limit. Minus, now I will put the lower limit. If I put minus 1 here, it becomes 0. If I put minus 1 here, so it is minus e to the power minus I u. X value is minus 1 upon, okay. Now plus. Now go to the second one. Now if I put upper limit here, this term will become 0. If I put upper limit here, e to the power minus iu upon I square u square, minus I will put the lower limit, that is 0. So it is e to the power, that become 1 upon minus iu, minus 0 means 1 upon I square u square. Correct? So now let me simplify all the terms. Let me see how much I am getting. 1 upon iu it is, right? So 1 upon iu plus 1 upon u square, because I square is minus 1, minus minus plus, and I square is minus 1. So minus e to the power minus iu upon u square, minus e to the power minus iu upon u square, because I square is minus 1. Then minus this I is there with negative sign. So this become plus. So plus 1 upon iu. Okay. And this is plus 1 upon u square. Right? See here, a very simple mistake. It is e to the power iux, and by mistake I have written minus iux, which will change everything. So this is plus. Let me see what are the changes coming because of that. So first function, integration of second. So e to the power iux upon iu. Minus. Okay. Better I will integrate this part again, because if you do the overwriting thing, it never comes the correct thing. So it's always better in maths, rather than searching the mistake or doing the overwriting, you should always do that part again. So let me do it again. So now see, first function, integration of other. Okay, minus integral d by dx of first and double integration of second. Correct? And limit is 0 to 1. Now let me put the limit. If I put 1, this term will become 0. If I put 1 here, e to the power iu upon I square u square. Minus if I put 0 here, so 1 upon iu. And if I put 0 here, so lower limit, so minus 1 upon I square u square. Right? Now let us open it. So 1 upon iu minus 1 upon I square u square plus e to the power minus iu upon I square u square plus e to the power iu upon I square u square minus 1 upon iu minus 1 upon I square u square. So if you observe, this and this will get cancelled. Correct? And now let me combine the remaining terms. Now this is I square. What is I square? I square is minus 1. This is also I square, which is minus 1. So basically 1 by u square and 1 by u square, which become 2 by u square. Same way here, I square if I take common, I square is minus 1. So minus 1 by u square in bracket e to the power iu plus e to the power minus iu. So this is 1 by u square if I take common, I am left with 2 minus, what is this? This is 2 cos u, right? So I can write it 2 upon u square 1 minus cos u. You can leave it like this also as an answer, and you can do it like this also, 2 sine square u by 2, which is equal to 4 by u sine square u by 2, that is half angle formula. So this is also correct, and if you stop here, this is also correct, right? Now let's move to the next question. So it is f of x is equal to e to the power minus mod x. So how I can do this question now? Again, as I explained you, f of x can take two values. One is minus mod x is minus x. This is applicable when x is less than 0. And e to the power minus of plus x. This is applicable when x is greater than 0. Now as such, Fourier transform is from minus infinity to infinity. F of x e to the power iux dx, correct? So let me put it. Now negative means number line, if you imagine, minus infinity to 0. So minus infinity to 0, fx will be e to the power x, e to the power iux dx, plus 0 to infinity. What is the value of the function? E to the power minus x, e to the power iux dx. Now, minus infinity to 0, e to the power x 1 plus iu, plus 0 to infinity, e to the power minus x 1 minus iu dx. Always remember, e to the power 0 is 1, e to the power infinity is not defined, and e to the power minus infinity is 0. So always try to avoid this condition and try to have negative in the exponential so that putting limit will be easy. I'm sorry. Now let's solve it. If I integrate this, okay, same way the other will be e to the power minus x 1 minus iu (0 to infinity). Now let us apply the limit. E to the power, first I put upper limit 0 and I have told e to the power 0 is 1, right? So 1 upon 1 plus iu minus, now I will put the lower limit. Now lower limit is minus infinity. So if I put e to the power minus infinity, I know it is 0, right? Then go to the second bracket for plus, if I put infinity here, so it become e to the power minus infinity, that is 0, okay? Now minus lower limit, if I put 0, e to the power 0 is 1. So 1 upon minus minus become plus 1 minus iu. So I have, if I consider these two terms, take the LCM, 1 minus iu plus 1 plus iu upon 1 plus iu, 1 minus iu. Okay, so this and this gone. 2 upon a plus b, a minus b formula is a square minus b square. So minus I square u square. So 2 upon I square is minus 1. So 1 plus u square. So this is my answer. Simple, right? So this is mod function. Looks like we feel it will be very complicated. But when you solve the question, the questions are very, very easy. So I hope you understood this. Now let's come to this function. This is also a mod function now. So in the same manner, I will split it into two functions, right? So I can rewrite this as, see, x e to the power minus of minus x when x is less than 0, and x e to the power minus of plus x when x is greater than 0, right? So my question become fx is equal to x e to the power x when x is from minus infinity to 0, and x e to the power minus x when x is from 0 to infinity. So this becomes my question. Now, what is the formula? Integral minus infinity to 0 fx So minus infinity to 0 is x e to the power x e to the power I u x dx plus x, it is 0 to infinity, x e to the power minus x e to the power I u x dx. Right? So now integral minus infinity to infinity x e to the power x 1 plus I u dx plus here integral x e to the power minus x I will take common, otherwise limit will trouble me. So 1 minus IU. Now you have to integrate it by parts. Okay. So I will show you both the integrals. This side x and e to the power x 1 plus IU. So differentiate it 1 0. Integrate it e to the power x 1 plus IU upon 1 plus IU. And e to the power x 1 plus IU upon 1 plus IU square. Cross cross minus plus. Okay. See, plus minus. Now next side. X e to the power minus x 1 minus IU. So 1 0 e to the power minus x 1 minus IU upon minus 1 minus IU. E to the power minus x 1 minus IU upon 1 minus IU square plus minus. So let me integrate and put it here. So x e to the power x 1 plus IU upon 1 plus IU minus e to the power x 1 plus IU upon 1 plus IU square minus infinity to 0 plus this side it is x e to the power minus x 1 minus IU minus e to the power minus x 1 minus IU upon 1 minus IU का square. And the limit is from 0 to infinity. Correct? Okay, that was below this. Wait, I forgot to write one term. So this has to go with this. So here minus 1 minus IU. This term is same. Right? This is one term. Right. So I got the integrals. Now let me put the limit. So first limit is upper limit, that is 0. When I put 0, this will become 0 because of x. When I put 0 here, e to the power 0 is 1. So minus 1 upon 1 plus IU square I got minus. Now I will put the lower limit. When I put minus infinity here, this will become again 0 because e to the power minus infinity is 0. And then since it is a lower limit, so again minus minus plus, but this will also become e to the power 0 is e to the power minus infinity is 0. So this both the terms are gone. Right? Come to the next term plus. Now if I put infinity, e to the power minus infinity is 0, e to the power minus infinity is again 0. So gone. Now put the lower limit, so minus. Now I am putting 0. If I put 0 here, this will become 0 because of this x. If I put 0 here, this will become plus. E to the power 0 is 1. 1 upon 1 minus IU ka square. Correct? So this is plus. So I got minus 1 minus IU ka square plus 1 plus IU ka square. And denominator, if I observe, it is 1 plus IU, 1 minus IU and square. So this will be equal to, okay, minus a square plus b square minus 2ab, okay, plus a square plus b square plus 2ab. So if you open the bracket, denominator also let me resolve. So a square minus I square u square ka whole square. So in the numerator I have minus 1 minus I square u square plus 2IU plus 1 plus I square u square plus 2iu upon 1 plus u square ka square. Okay, so now here 1 minus 1 gone, this term and this term gone. So 4iu upon 1 plus u square ka square. So this is what I got as my answer. Okay, so this is my answer. So with this question, the type of questions I have done, you have got all the variety of simple complex Fourier transform. So I hope you understood the concept and you will like it. So like the video, share the video and subscribe the video. Thank you.